We think we get light, right? Flip a switch, it's on. Flip it again, it's off. Super simple. But what if I told you that straight line you learned about in school? Well, that's just chapter 1 of a story that bends, curves, and gets, well, a little bit weird. So let's dive in and unravel this thing.
Okay, so let's start with a really, really simple question. I want you to picture this. You're in a room. It's completely pitch black. You're in there, all the furniture's in there, so why can't you see anything? I mean, what's actually missing?
And the answer, it's almost elegant in its simplicity. We see stuff because light from, say, a lamp hits an object, bounces off it, and then travels in a perfectly straight line right into our eyes. So if there's no light to begin with, or if something gets in the way of that straight path, well, that information just never makes it to us. Simple as that.
So this core idea that light travels in a straight line, that's the foundation. It's the bedrock for everything else we're going to talk about. Think of it as rule number 1 in the Book of Light.
And of course, scientists had to give this a fancy name, right? They call it rectilinear propagation. It sounds complicated, but all it really means is that as long as light is cruising through the same stuff, like air or water or glass, it's going to stick to that straight and narrow path. No detours.
There's a super simple experiment you can do that proves this perfectly. Just picture lining up 3 pieces of cardboard, and each one has a tiny little pinhole right in the center. Now, if you put a candle at one end, you can only see that flame from the other end if those 3 holes are lined up perfectly. I mean, you move one of them just a millimeter to the side, poof, the light's gone. It's so simple, but it's incredibly powerful proof.
Okay, so is that it? Is that the whole story? Does light just always go in a straight line no matter what? Well, as you can probably guess, this is where our straight story starts to get some twists.
Turns out there are 2 main ways light can get knocked off its straight line course. First, it can bounce off a surface. We call that reflection. Or second, it can actually bend when it passes from one thing into another. That's called refraction. So just remember those 2, bouncing and bending. Those are the big rule breakers. So let's look at reflection first. Now you probably think of mirrors, right? But get this, reflection is happening everywhere, all the time. A mirror is special because it's super smooth, so it gives you what's called even reflection. All the light rays bounce off at the same angle and you get a nice clear image. But look at something like a piece of paper. It seems smooth, but it's actually rough on a microscopic level. It causes uneven reflection. The light still bounces, but it scatters in a million different directions. And that is exactly why you can see the paper, but you can't see your face in it. Isn't that cool?
All right, now for the other one, bending or refraction. And here's the secret sauce. It's all about speed. Light is like a race car. It zips through the air super fast, but the second it hits something denser, like water, it's like hitting a patch of mud. It slows down. And it's that sudden change in speed that causes its path to bend.
I guarantee you've seen this 1,000 times without even thinking about it. You know when you put a straw in a glass of water and it looks like it's broken right at the surface? That's refraction. It's why the bottom of a swimming pool always looks closer than it actually is. Your brain is hardwired to think light travels in a straight line, but refraction is playing a clever little trick on your eyes. It's not magic, it's just pure physics.
Okay, so let's recap. We've got light going straight, we've got it bouncing, and we've got it bending. It kind of feels like a bunch of separate rules, right? But what if I told you there's one single, elegant master principle that explains all of it? A deeper why behind everything light does.
And here it is. It comes from a French mathematician named Pierre de Fermat, and it is just beautiful. He said that of all the possible paths light could take to get from point A to point B, it will always choose the one that takes the least amount of time. Not the shortest distance necessarily, but the shortest time.
And boom, that right there explains our very first rule. Think about it. If light is just traveling through air, its speed is constant. So how do you take the least amount of time? You take the shortest path. And what's the shortest path between 2 points? A straight line. See how Fermat's principle perfectly explains why light travels straight? It's all connected.
But hold on, our story isn't over. There's one more massive mind-bending twist. So far, we've seen light change course by bouncing off things or passing through them. But what if something could bend light without ever even touching it?
And this is where the one and only Albert Einstein enters the picture. He came up with this completely revolutionary idea that gravity isn't just some invisible force pulling things down.
He said that massive objects actually bend and warp the very fabric of space and time. The classic example is to imagine a bowling ball on a trampoline. It creates a big dip. Well, that's what stars and galaxies are doing to the fabric of the universe.
So what happens when a beam of light flies past one of these massive objects? Well, it has no choice but to follow the curve in space. It's still taking the straightest path it can, it's still following Fermat's principle of least time, but now the path itself is curved. This incredible phenomenon is called gravitational lensing, and it's wild. It lets astronomers see galaxies that are hidden behind other massive galaxies in the foreground.
All right, let's bring it all home. We started this journey in a simple dark room, and we ended up warping the fabric of space-time. So let's quickly recap the complete, amazing story of light.
So, here's the whole shebang. Light travels straight. Think of a flashlight beam, because that's the quickest path through any one thing. It bends, like that broken straw, because sometimes taking a slight detour and changing speed is actually faster overall. And it curves through space because it's just following the contours laid down by gravity. You've got straight, bent, and curved paths, but they all obey one beautiful underlying rule. Light is always in a hurry. It always takes the path of least time.
And just when you think you've finally wrapped your head around it all, quantum physics throws us a curveball. It's a beautiful one, though. At the super tiny level, a single particle of light, a photon, doesn't just pick the fastest path. It actually, in a way we can barely comprehend, explores every single possible path all at the same time. The path we end up seeing is just the one that gets reinforced, the one where all the possibilities line up. And which path is that? You guessed it, the path of least time. I mean, how cool is that?
So that's where we'll leave it. We started with a really simple question about a dark room, and it unfolded into a principle that governs the entire universe. It really makes you think, doesn't it? If something as basic as the path of light is actually this complex, this full of twists, bends, and quantum weirdness, what other simple rules of our universe are just waiting for us to ask the right questions and take a closer look?